Imagine hiring the most brilliant assistant in the world. They solve any problem you give them instantly, but there's a catch. The moment they walk out of the room, they forget you completely. Everything, your name, your project, the entire conversation. And tomorrow, you have to start from zero, all over again. That by default is exactly what a language model is, a genius with amnesia. Every new chat begins with a completely blank mind. It doesn't remember your last conversation or even the start of this one once it's long enough. On its own, the model has no memory. And you feel it, the assistant that can't recall a preference you stated 5 minutes ago, the one you have to re-explain your whole situation to every single time. Without memory, an AI can be clever, but it can never really know you, and it can never carry a long task from one day to the next. It's a strange kind of Groundhog Day. To the assistant, every conversation is the first one it has ever had with you. All the rapport you built yesterday, all the context you painstakingly gave it, gone overnight. You're not working with a colleague who's getting to know you. You're rebriefing a stranger again and again. So we builded a memory, not one memory but a whole system that lets an agent hold onto the thread of a conversation and remember you across days, weeks, months. It's the difference between a tool you use and an assistant that grows with you. This is the memory block from my video on agentic design, opened all the way up. What memory really is, the two very different kinds, and how an agent decides what to keep and what to let go. Let's build it piece by piece. Part 1. Two kinds of memory. The word memory sounds like one thing, but for an AI agent it's really two, and they work completely differently. Getting this split clear is the key to everything that follows. The short-term memory. This is what the agent holds during a single conversation. The things you just said, the steps it just took, the result the tool just returned. It's fast, it's right there, and it's what lets the agent stay coherent from one sentence to the next. Second is long-term memory. This is what survives after the conversation ends, your preferences, key facts about you, important things that happened in past sessions. Close the chat, come back a week later, and long-term memory is what lets the agent still know who you are. Think of your own mind for a second. Short-term memory is what you're holding in your head right this instant, the beginning of this very sentence, a phone number someone just read out, fragile and gone in moments if you don't act on it. Long-term memory is what you'll still know next year, your best friend's name, how to ride a bike. The two are stored in completely different ways, used for different things, and a capable agent, just like a capable person, needs both. So short-term for the current conversation, long-term for everything after. Let's take them one at a time, starting with the one you've actually met before, maybe without realizing it. Part 2, short-term memory. Here's the surprising part. You already know exactly what an agent's short-term memory is because we spent a whole video on it. It's the context window. Everything the model can see right now, in this turn, your messages, its replies, tool results, is its short-term working memory. If it's in the window, the agent remembers it. And the instant it's not, the agent has no idea it ever existed. The window is the agent's present moment. But that window, as we saw in my video on context engineering, has a hard limit, a budget. It can only hold so much at once. And in a long conversation or a long task with lots of tool results piling up, you eventually run out of room. Something has to give. The oldest parts of the conversation start to slide off the edge of the window, and as far as the agent is concerned, they simply cease to exist. And this is the classic failure. You have a long, rich chat with an assistant, and halfway through it forgets something you said at the very beginning because that part has scrolled out of the window entirely. Short-term memory is powerful, but it's volatile and it's small. So what do we do when it fills up? We can't just let the beginning of every long conversation disappear. We need a way to hold on to what mattered without keeping every single word, and that's a beautiful little trick. 3. Making room. When short-term memory starts to fill, the answer isn't to keep everything or to throw the old stuff away. It's to compress it, to keep the meaning while dropping the bulk. The main tool is summarization. As a conversation grows long, the agent quietly takes the older parts and boils them down into a short summary. 10 back-and-forth exchanges about planning a trip collapse into a single line. The user is planning a 5-day trip to Japan in April on a mid-range budget. The exact wording is gone. Dozens of sentences become one. But the essential meaning, the gist the agent actually needs going forward, is preserved. This is often called a rolling summary. The agent keeps a running gist of everything so far, updating it as the conversation moves. The recent messages stay word for word because they matter most. The distant ones live on, compressed in the summary. It's exactly the compression idea from my context engineering video, working as memory. And there's a real trade-off here. Summarize too aggressively and you lose a detail that turns out to matter. Summarize too little and you run out of room. Deciding what to keep in full and what to compress is one of the quiet arts of building a good agent. So summarization stretches short-term memory a long way, but it can't last forever and it can't survive the chat being closed. For anything that needs to truly last, we need somewhere else to put it. Part 4, Long-term memory. Everything so far lives and dies with a single conversation. Long-term memory breaks that. It's a store that sits outside the model and outside any one chat, holding on to things for as long as we want. Picture it as a notebook the agent keeps open beside it, a database sitting apart from the model itself. It is not automatically part of the conversation. The way the context window is, the model can't see it just by existing. Instead, the agent has to work with it through two deliberate, separate actions. It can write to it, and it can read from it. Everything about long-term memory comes down to those two moves. Writing is saving something worth keeping. At the end of a conversation or the moment something important comes up, the agent records a note in its store. The user prefers window seats. The project deadline is the 15th. These notes sit there, patiently, long after the chat is closed. Reading is bringing a saved note back. When you return days later, start a conversation, the agent looks into its store, pulls out the notes that are relevant to what you're now talking about, and drops them into its context window, its short-term memory, so it can use them. Write to remember, read to recall. Simple to say. But each of those two steps hides a genuinely hard question, and getting them right is what separates an agent that feels thoughtful from one that feels creepy or clueless. Part 5, What's worth remembering. Start with writing. The naive idea is to just save everything, record every message, every detail forever, and it's a terrible idea. An agent that remembers absolutely everything is as useless as one that remembers nothing. Because a memory store crammed with every trivial detail becomes impossible to search. The one fact that matters is buried under 10,000 that don't. Good memory isn't about saving the most, it's about saving the right things. It takes real judgment about what will matter later. So what's worth keeping? A few clear kinds, stable facts about you. Your name, your role, that you're vegetarian, your preferences, you like short answers, you work in metric and key events. A decision you made, a problem you hit, the outcome of a big task. The things a thoughtful human assistant would jot down, and nothing more. Here's the feel of it in practice. You mention in passing that you're allergic to peanuts. A good agent flags that as worth keeping forever. It's stable, it's important, it'll matter every time food comes up. But the fact that you said good morning at the start of the chat. Not worth a line in the notebook. That instinct for what's durable and important versus what's fleeting and trivial is exactly what the writing step is trying to capture. The technical name for this is salience, judging what's important enough to remember. Sometimes the agent decides for itself, sometimes it's told explicitly, remember this. Either way, that filter, between the flood of everything said and the few things kept, is one of the most important parts of the whole system. So the agent has carefully written down a handful of things that matter. Now comes the other half, and in some ways the harder half, getting the right memory back at exactly the right moment. Part 6, Bringing it back. A memory you can't recall at the right time might as well not exist. So when you start a new conversation, how does the agent decide which of its saved notes to pull back in? It can't just load all of them. A memory store might hold thousands of notes, far too many to fit in the context window, and dumping them all in would drown out your actual question. It has to select. Only the memories relevant to what you're talking about right now get pulled back. And the way it does that should sound familiar. It's retrieval, the exact machinery from my video on RAG. Your current message becomes a kind of search query, and the agent searches its memory store for the notes most related to it. Ask about dinner plans, and it surfaces that you're vegetarian. Ask about the project, and it pulls up the deadline. The relevant past, and only the relevant past, comes forward. Really, both your memories and your question get turned into that same mathematical fingerprint we built up in the RAG video, a point in a kind of meaning space. The agent then simply grabs the saved notes whose fingerprints sit closest to your questions. No keyword matching, no rummaging through everything, just a fast reach for the handful of memories that are actually about what you're asking. Those recalled notes then slide into the context window, and from the model's point of view, they're simply part of what it knows now. The agent doesn't feel like it's looking something up, it just remembers, smoothly, as if it had known all along. Now, if you've been paying close attention, something might be bothering you. This retrieval step sounds an awful lot like RAG, so what's actually the difference between memory and RAG? Part 7, Memory versus RAG. This trips up almost everyone, and for good reason. Both memory and RAG pull relevant information into the context window using retrieval. Mechanically, they're cousins, but what they're for and where their information comes from is completely different. RAG reaches into a body of shared external knowledge, company documents, a help center, a textbook, information that exists independently of you that anyone using the system would draw from the same way. RAG is the agent looking things up in a library. Memory reaches into your personal accumulated history, notes the agent itself wrote about you from your past conversations. Nobody else has your memory store. It's not a library. It's a diary the agent keeps about its relationship with you specifically. So here's the clean line to hold on to. RAG is knowledge, facts about the world, looked up when needed. Memory is experience, things that actually happened between you and the agent, recalled when relevant. One makes the agent knowledgeable, able to answer from a shared body of truth. The other makes it feel like it genuinely knows you. Same underlying retrieval engine, two completely different jobs, and a serious assistant uses both at once. So memory is the agent's personal history, written and recalled, which is powerful and, as anyone with a long history knows, also a source of some very real problems. Part 8, When memory goes wrong. A memory system that only ever adds and never forgets or updates quietly rots over time. There are a few classic ways it breaks, and every serious agent has to plan for them. The first and most common is staleness. You told the agent a year ago that you live in New York. It dutifully remembers forever. But now you've moved to London, and it keeps confidently bringing up the old city, recommending the old restaurants, assuming the old time zone. A memory that was perfectly true once and is simply wrong now can be far worse than no memory at all, because the agent states it with total confidence. Memories need to be updated and sometimes quietly retired. The second is conflict. Old note, the user is a beginner. New note, the user is clearly an expert. Which does the agent trust? Without a way to resolve contradictions and to prefer the newer, truer version, it ends up confused, pulled in two directions by its own past. The third we've met before, clutter. Remember too much and you drown the important in the trivial. The context rot from my agentic and context engineering videos applies here too. The best memory systems forget on purpose. Letting go of what no longer matters is not a bug, it's a feature. And there's one more which isn't technical at all: privacy. An agent that remembers everything about you is holding something genuinely sensitive. What it keeps, how long it keeps it, and whether you can see and delete it aren't afterthoughts. They're a basic matter of trust. Freshness, consistency, restraint, and trust. Get those right, and memory quietly transforms an agent. We've built the whole system. Let's step back and see the complete picture. So here's memory whole. Short term, the context window holding the here and now, stretched by summarization. And long term, a store outside the model, written to when something matters and read from when it becomes relevant again. Systems working together, so an agent can hold a thought and hold a relationship. And notice where it lives, right inside the agent loop from my video on tools. At the start of a task, the agent reads, pulling relevant memories in. As it works, short-term memory holds the thread, and at the end it writes, saving what's worth keeping for next time. Recall, work, remember. Every loop a little wiser than the last. And if you keep just one idea from all of this, keep this one. The model itself never changes. It learns nothing new between your conversations. Its actual intelligence is frozen the day it was trained. So all of this apparent growth, the uncanny way a good assistant seems to gradually get to know you, isn't the model getting smarter at all. It's a memory system sitting alongside it, carefully deciding what to carry forward and what to let go. The intelligence was always there. Memory is simply what gives it continuity and a past. Give a brilliant, forgetful mind a way to remember and thoughtful judgment about what to keep, and it stops being a tool you use once and starts being an assistant that grows alongside you. If this made memory click, give it a like, it really helps the channel. And subscribe, because next we look at planning how an agent breaks a big, hard goal into the right sequence of steps. We're building AI up from the ground, one blueprint at a time. Thanks for building it with me. See you in the next one.